Okay. First is analytical thinking, active learning, complex problem solving, critical thinking, creativity, leadership and social influence, technology use, technology design, resilience, stress tolerance, reasoning, problem solving, and ideation. All right. So in this list, you also see top 10 skills in 2020, top 10 skills in 2015. All right. So as you can see here, they are different. In 2015, the kind of skills needed are different from skills needed in 2020. And in 2025, as you can see, is totally different. 2015 and 2025, they have some similarity. But in 2025, it's totally different. Because what? Because now we have COVID. Yeah, we have COVID. It changed the whole thing. It changed everything. So in 2025, you will see a different world. Even next year, you will see different world. 2 years from now, when you graduate, it's totally different world. So it's better for you to learn all these skills, right? Okay, why I feel that I have to show you this list, okay? Because what? Because without these skills, you will find difficulties to survive. Yeah, without these skills, you will find difficulties to survive. You cannot get job just like this. You know, I showed to student this morning. Someone graduated from, not from chemistry, from biotechnology. She couldn't find job for 2 years. She already sent over 800 job application. 800, I don't know, like how she can write 800 job application letter, but apparently she did. 800 job application for 2 years, she got nothing, no jobs. Okay, because during her study, she did not learn all the skills. What mostly students did, and this is a huge mistake, I have to tell you, this is a huge mistake. During your study, the only goal in your mind is to pass the exam. That's it, to pass the exam. Yeah, that's the only thing that crossed your mind. How can you pass the exam? You got A and CGPA close to 4.0. Of course, CGPA is important, but it's not stated here. CGPA is important, but it's not stated here. Nothing. No CGPA here. But of course, getting good CGPA is important, because when you try to find a job, good CGPA means you take your study seriously. You don't play around, you take your study seriously, it's fine. Having good CGPA is good. But the most important thing is you have to have all these skills. Without these skills, you will end up 2 years, 3 years, 4 years with no job. Okay? You want to have jobs, right? You want to stay in your parents' house asking money from them for the rest of your life, right? You want to find job and you help your parents, you help your siblings, right? You help other people. That's what you want. And in order to do that, you must have these top 10 skills. This is the reason why if student ask me, Dokter, topik ni masuk exam tak? Dokter, this topic will be included in the exam or not? I will not answer. Or student ask, Dokter, how many questions during the exam? How many questions? A, B, C ke? I will not answer that. Because what? Because I know you learn nothing from my lecture. You learn nothing. You just want to pass your exam. Because I want you to be able to think analytically. I want you to be able to learn actively, active learning. Don't just ask me how many questions will be asked during the exam. Don't ask me what topics will be asked during the exam, because it means it's passive learning. You know, most students, they expect the question will come from the lecture notes. No, it means passive learning. Active learning means you learn by yourself. Lecture note is your guideline, yeah. So you know what to study, yeah. But you have to improve your knowledge by reading some other sources. Wikipedia is a good source. You know, I don't ban my student from learning from Wikipedia. You know, It's different from 15 years ago, 10 years ago. During that time, Wikipedia was not reliable. Now, I think a lot of people are able to improve the quality of Wikipedia. Free textbook, even in YouTube, all those in Coursera. So there is no limit for you to learn by yourself, active learning and learning strategies. Yeah. You are taking 5-6 subjects this semester, and each subject, it has a lot of topics like protein chemistry, a lot of topics, sampai pening kan. Even protein biosynthesis on Wednesday pun dah pening. Today will be more pening lah. And you need to strategize. You need to strategize because you have to learn a lot, yeah. But how to strategize so that you don't get stressed out, you don't get depressed? Because see this number 9, resilience, stress tolerance, and flexibility. You have to be able to manage your stress. You have to be resilient because in 2025, the world will be a very stressful place. You have to learn how to manage stress from now. And flexibility. You have to be very flexible, You don't get CGPA 4.0, oh, fine. That's fine. Of course, it's good. You aim for CGPA 4.0, just in case you get 3.8 or you get 3.71. You don't get 4.0. That's fine. So you have to be able to be flexible. Flexible with your goal, flexible with what you want. Yeah? Because otherwise you will get stressed out. You don't get what you want. And then you get stressed out. You get depressed. And then you're in trouble, So you have to learn how to manage your stress, how to manage your expectation, and be flexible. I tell you, my CGPA was not good. My CGPA is only 3.12. When I finished my first degree, only 3.12 with 2 Ds. I got D in my academic transcript. I got 2 Ds. Both are organic chemistry because I didn't like organic chemistry. I got Ds in my transcript. But I told myself, that's okay. That's okay. Maybe it's not my strength. Organic chemistry is not my strength. And that's okay for me. All right. And I end up doing my postgraduate study. I try to avoid organic chemistry because I know organic chemistry is not my forte, it's not my strength. I try to avoid organic chemistry. I did biochemistry because biochemistry is my strength. So during postgraduate study, I know what I'm not good at. I know what I'm good at, If you got A for everything, you don't know, you will not know what you are not good at. Oh, I'm good in organic chemistry. Oh, I'm good in analytical chemistry. Oh, I'm good in spectroscopy. Oh, I'm good in computational chemistry. So where you are not good at, you don't know. But now I know because my biochemistry is good. My mathematics is very bad. My organic chemistry is bad because I got D. So I know that, oh, I'm good in biochemistry. So during my postgraduate, during my master and PhD, I took biochemistry, right? So be flexible with your expectation. Be flexible with your goal, and you will be successful. Yeah. Creativity, originality, initiative, very important. Leadership and social influence. Leadership. If I give you group assignment and your friends appoint you as group leader, don't chicken out. Don't avoid that. Oh, jangan saya lah, saya malu. No, take it up. Take up the challenge because this is the time for you. You have 4 years to learn how to become leader because I tell you, man, you will need it. You will need it in the future. You are going to need it. So it's better for you to learn now or never. Learn now, So you have group assignment. Before someone nominate them as leader, you nominate yourself. Hey, I want to be a leader. Because this is an opportunity for you to polish your leadership skill. Social influence. You use Facebook, you use Instagram. Use it to strengthen your influence. Use it to spread the knowledge about chemistry. You talk about chemistry in your social media. So grow your followers, not because you show something stupid in social media, but you spread the knowledge, right? Social influence is very important in 2025. Yeah, you have to make yourself visible. You have to make yourself known by other people. Don't just keep yourself in your room, you know. You have to make yourself visible and known, all right? So all these skills you need to learn from now, all right? CGPA is important, but these top 10 skills are more important. So every time I give you assignment, don't take it as a burden. Oh, the assignment lagi, Dr. Bimo bagi assignment. No, don't take it as a burden. If you take it as a burden, you will suffer. I tell you, you suffer for 4 years is not fun. You know, 4 years you suffer in university is not fun. Take it as learning experience. I give you assignment, take it as an opportunity for you to learn how to think analytically. Take it as an opportunity for you to learn how to strategize your learning process. Take it as an opportunity for you to learn how to solve problem, how to solve a complex problem. Yeah, a lot of assignments, a lot of homework, not only from me, from other lecturers as well. Don't take it as a burden. Take it as an experience for, as an opportunity for you to learn how to manage stress, to learn how to be flexible with your goal, with your time as well, and learn how to be resilient. Because all these things that you experience for 4 years actually is learning experience for you, so that you can master all these skills. When you graduate, you have all these skills. Yeah. So again, don't take it as a burden. Yeah. I know it's very challenging for you, especially during pandemic. You have to learn everything online, but take it as a learning experience. You will learn all these things. So every time you have something in front of you, ask yourself, am I learning something from this? Am I learning something about leadership? Am I learning something about creativity? Am I learning something about complex problem solving? Am I learning something about analytical thinking? Am I learning something about innovation? Ask yourself. All right. So yeah, because I don't want you to end up being jobless after finishing your study, you know, because it's hurtful for us, you know, as educator, as your lecturer, if you end up being jobless without any job after you graduate. But of course, you have to play your part. Yeah, you have to play your role, you know. And now you know, because I tell you this morning, this is the top 10 skills that you have to have. Top 10 skills that you have. All right. So you have 2 years more to graduate, right? You are second year student, right? Right now, or first year student, third year student? I don't know.
Third year.
Third year. Third year. So you have 1 year to graduate. Ask yourself, do you have these skills? Kalau you tak ada these skills, you have 1 year to polish your skill. Okay? Just make sure you have these skills. Because at the end of the day, when you apply for a job, you know, your employer will look at your CGPA, fine, but they will interview you. You ada tak this leadership quality? You ada tak this ability to think critically? You ada tak this technology design and programming technology use? That's why, in my case, yeah, for practical, for lab, I ask my student to write a report using computer, to draw the chemical structure using computer, because I want my student to be able to use technology. This is 2020, man. It's not 1920. You have to be able to use computer. Drawing the chemical structure, oh my God. If you don't know how to use software, better you learn from now. You learn from now how to draw chemical structure using software. You cannot use technology hub-based. You have to be able to use technology, because this is one of the top 10 skills. I want you to have these top 10 skills. Okay? So, again, don't ask me this topic will be included in the exam or not. Don't ask me how many questions will be in the exam. Don't ask me. Because if you ask me and I answer you, you learn nothing. You learn nothing. Yeah? So, all right. So yeah, that's something that I feel is quite important for you to know. Yeah, because this is for you, yeah, not for me. I'm done with my life. I'm done. You know, I have a very satisfying career. Yeah, for the past 20 years. This is for you, right? Okay, so let's continue with the protein chemistry. Yeah. You can see my slides, right? Chemistry of nucleotides.
Yes.
All right.
Yes.
Okay. All right. Okay, before I continue, I want to get some feedback from you. Compared to face-to-face, do you think online teaching or online learning is more stressful? Because we start getting some, not complaints, some feedback from students that this is more stressful compared to face-to-face. Is it true? Can some of you give me some feedback?
Yes.
More stressful? Why?
Yes.
Why?
For
Because
me, I have a
yeah.
strong internet connection, so sometimes I didn't hear you clearly how you explain, and then I miss some points.
Okay. Internet connection, yeah. All right. Okay. So, okay, point taken. Yeah. Anyone? Anyone else? Ada apa? Other feedback? Internet connection, yes. Yes. I have to admit that's the one of the biggest challenges. Yeah. During online teaching. Any other feedback other than internet connection?
We are easily distracted by the surrounding.
Ya. Kena jaga adik, kena masak, semua kan. So,
Yes.
Right.
so it's easier if you stay in college kan, in residential college, so no distraction. But if you are at
Yes.
home, of course they will be. Same with me. I have kid as well, and I have cat at home, so the cat always distract me. Yeah, so same thing. Yeah, so for me it's quite difficult as well. Yeah. Okay. Point taken. Yeah. So we have the same issue, but at least for me, internet connection in my side is quite good. Yeah. But in terms of distraction, yes, I do have distraction as well at home. Yeah. Any other feedback other than internet connection, distraction at home? What about is it more difficult for you to understand the topic compared to face other than internet connection memang ada masalah lah, but in class when you listen to me and now you listen to me through internet, is it does it affect your understanding? Tak ada yang jawab.
Not the subject, doctor, but some other subject that require drawing.
Oh, okay. I see. Okay, now I understand. Yeah. My subject, it doesn't require you to draw, but some subject, yeah, they ask you to draw chemical structure. All right. Okay. So this is where your active learning skill will help you. Okay. This is where your active learning skill will help you. I show you the list of top 10 skills, right? One of it is active learning skill, right? It's not enough if you just rely on our lecture. Okay, it's not enough. Yeah? If you just rely on my lecture, it's not enough for you. All right. So my advice is there are plenty of free online lecture. Yeah, there is a Khan Academy, and then there is a Professor Dave. Yeah, in YouTube. Yeah, it's very interesting. I saw it. Yeah, I watched it. Professor Dave punya online class. It's very interesting as well. You can use that to help your understanding. You can use it. we are okay with that. Yeah? Even we discuss among lecturers, we are okay with that, yeah? Because we know there is a limitation. Yeah, there is a limitation about the teaching delivery, right? So it's okay if you want to refer to other online lecture, yeah, that you can get easily from YouTube or other sources to help you understand the topic better. Okay. During my time, we used textbook, yeah, 20, 30 years ago, yeah. After the lecture, we have lecture notes, of course, but at the same time, we have textbook, yeah. So reading textbook helped us a lot to understand the topic, right? But right now, students don't have textbook, right? Nobody buy textbook anymore, even though actually it's a good practice to buy textbook. But now students can get, free online lecture from internet, from YouTube. You can Google it, you can get from any other sources. So actually it's just like textbook. Yeah. So don't just rely on one source, which is my lecture notes. Don't rely on one source. Yeah. So as I told you, in the top 10 skills needed in 2025, active learning. Yeah. You have to be able to actively learn by yourself, and also to strategize your learning. How to strategize. You have internet connection issue, and how to solve that problem. Of course, reading my slide is not enough. You get other sources to improve your understanding about this topic. Yeah. But of course, there are other problems will come. Yeah. About the internet quota. Yeah. It will cost you money to buy internet quota. Yeah. But I don't know whether you know that the ministry already put some allocation to help a college student, university student, to buy more internet quota. Did you know that? They,
Yes.
yeah. I don't know whether I don't know how you get that money, but it becomes a concern of our ministry as well. Yeah. So if you have more quota, yeah. So if you have more data, then you can download more resources. So you can study better. Yeah. That's how we solve this issue. Yeah. So you don't rely on only one source, which is my lecture notes. No, you are free to 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 use other sources as well. Yeah. Any other issue with online teaching other than that? What about the lab? What about the lab? I know you are not able to touch the equipment. You cannot feel, that you don't get that feeling. You cannot touch the instrument. You cannot see the instrument in front of you. You see everything online through video. Is it a problem for you? Not really.
Yes, problem because you
Lab
have
skill.
lack of experience.
Yeah,
Lab
because
experience.
lab experience is true, but basically in reality, for CHM three, sometimes like CHM 3402, the subject that I'm teaching, in reality, students will just watch the experiment. Yeah, they don't really operate the machine. But for some labs, yes, for some subjects, you have to do it by yourself, like oleochemistry. You have to know how to use a burette to do titration. So without those skills, I'm worried that when you find a job, and then you have to do something in the lab, you don't have that skill, and then your employer will get upset with you. Yeah, of course, it become our concern as well. And inshallah, next year things will go back to normal. Yeah, at least it will be better. Yeah, inshallah. Yeah, so you can go back to the lab and do the practical. Yeah. Okay, so there are some challenges, that we are facing. Yeah, not only you, lecturers also, we are facing the same issue. Yeah. But inshallah we'll manage. Yeah, we will move forward. Yeah, so inshallah next year will be better. All right. let's continue with nucleotides. So this is actually a more detailed explanation about what you learn on Wednesday. Yeah. So on Wednesday you learn how protein biosynthesis happen, yeah, in the cell. Yeah, it's just basic principles. But today, yeah, this week and next week, we will see this process in a more a detailed way. Yeah, about the nucleotide and about protein biosynthesis. So learning objective, yeah. So you will learn about the nucleotide definition and structure, DNA and RNA, nucleotide biosynthesis, and then a protein biosynthesis. And at the end of the lecture, we expect you to be able to discuss nucleotide structure, elaborate DNA, RNA nucleotides, discuss on nucleotide synthesis, and describe protein biosynthesis. I don't expect you to memorize, but I expect you to understand. Yeah, I don't put any student have to be able to memorize blah 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 blah. No, yeah. But of course, some basic concepts need to be memorized. Yeah, but most of the time, you have to understand the concept instead of memorizing it. Yeah. All right. So this is a nucleotide. Yeah, we discussed a bit on Wednesday. Yeah. So nucleotide consists of phosphate. Yeah, either diphosphate or triphosphate. Yeah, it's a phosphate group, right? And then the sugar, yeah, in the middle part. Yeah, and then the base. Yeah, this is the base, right? So base can consist of adenine. Yeah, this is different bases. Yeah, guanine, cytosine, uracil, or thymine. Yeah. So depending on what kind of base you have, then you will have a different nucleotide. Yeah. For adenine, this is the base that they have. Guanine, this is the base. Cytosine, base. Uracil, and thymine. Yeah. So you have base, you have sugar, and you have phosphate. Yeah. So that's the nucleotide. It's a bit history. Yeah. So Friedrich Mischer, he isolated nuclein from cells. Yeah. 200 years ago. Yeah. So it contained unknown phosphate-rich substance. So during that time, he didn't exactly know what he isolated. What he know is just, it's a phosphate-rich substance. Yeah? It has a lot of phosphate. Yeah? And the properties, it's one of the properties is acidic. Yeah? So that's why he called it as nucleic acid. Yeah? And then Albrecht Kossel differentiated RNA and DNA, yeah, ribonucleic acid and deoxynucleic acid. You learn the difference between RNA and DNA in my lecture on Wednesday. So basically, yeah, the difference is here. Yeah, the difference is in sugar group. Yeah. For RNA, yeah, ribonucleic acid, you have ribose. Yeah, you have OH here. But with the DNA, deoxyribonucleic acid, instead of OH, you have H. Yeah, here in this side. Yeah. So that's the difference between DNA and RNA, right? So, and then in 1906, yeah, Kossel, the same person, described 4 bases of nucleic acid, yeah, A, T, C, and G. And he got Nobel Prize in 1910. Yeah, so that's nucleic acid. Nucleic acid is known as information molecules. It's a blueprint of you. It's your blueprint. Yeah. And you inherit this from your parents, and you will pass this information to your offspring. Yeah, to your children. Okay, they store genetic information. Yeah, in most organisms, including us, including human, we have DNA and RNA. And if you still remember from my lecture on Wednesday, so from DNA becomes RNA, and RNA becomes protein. Yeah, so it starts from DNA. Yeah? But in some viruses, they have only DNA or RNA, because virus, it's simple. It's not even organism. It's not organism because they cannot reproduce by themselves. Yeah, they need to find a host. They need to find a host so that they can reproduce. If the virus is located somewhere, for example, COVID-19 virus, yeah, SARS-CoV-2, if the virus is not inside our body, the virus cannot replicate. They cannot reproduce. We don't call them as organism because they cannot reproduce. They cannot have metabolism, and they can be killed easily. You can kill them using soap, just normal soap. You can kill them, or you can kill them using alcohol. You can kill them using Clorox. Yeah, even sunlight and heat can kill them. You can kill them easily because they're not organism. They are not organism as long as they are outside our body. But when they get inside our body, then they will become organisms. They can reproduce, they can replicate, even they can destroy our body. So that's the reason why you have to wear masks, because it's easier for us to kill the virus when the virus is outside our body. Because this virus only has RNA. They don't have DNA. So they cannot reproduce by themselves, because in order for them to reproduce by themselves, they must have DNA and RNA, just like us. We can reproduce by ourselves, right? Because we have DNA and RNA. But virus, either DNA or RNA, they don't have both. So when the virus is RNA virus, they need our DNA. When the virus is DNA virus, they need our RNA. Yeah. So once they're outside our body, they are not organism. We can kill them easily. But once they get in our body, they get into our body, then things become complicated because they become organism. They have their own metabolism. They can reproduce themselves. So killing them becomes very difficult. You need drug, you need vaccine, you need everything. And until now, we don't have vaccine for COVID-19. Some are approaching, yeah. We got report that some vaccines, one vaccine from Pfizer is 90% effective. Vaccine from Russia is 92% effective, but we are still not sure. Drug, there is no drug at the moment, yeah, an effective drug for COVID-19. So that's why you need to put your mask on, because once the virus gets into our body, it's very difficult to kill them because they become organisms. If the virus is outside our body, it's very easy to kill them. It's very basic principle, but we see more and more people don't put their mask on. You attend my lecture, now you know why. Now you know why. All right, so always follow SOP. That's what our Tan Sri DG always say every day. Always follow SOP, because he know and we know that it's easier to kill the virus when the virus is outside our body. Okay, so DNA and RNA, yeah, they not only store information but also transmit information. Yeah, as you can see on Wednesday, yeah, they transmit the information from DNA to RNA. Yeah, so from the sequence of DNA, you get the RNA, and from the sequence of RNA, you get the protein. All right. So they keep the information, they store the information, but at the same time, they can also transmit the information, right? In the form of coded form, yeah, ACGT. Yeah, so this is the structure of DNA and RNA. Yeah. For RNA, normally it's a single strand. For DNA, it's double strand. Yeah. So DNA stores information about amino acid sequence of protein. Yeah. So what kind of protein that you will get depends on the DNA. Yeah. And DNA will become RNA, and and from RNA, the protein synthesis will occur. Yeah, from the RNA. Right. So okay, so let's talk more detail about the building block. Yeah. So the building block is nucleic acids, high molecular weight of biopolymers. The building blocks are mononucleotide. Yeah, so they contain CHO, N, and P. Yeah, so it's very simple. Building block is very simple. Yeah, it contains CHO, N, and P. It's so simple. You can find this in other planets as well, not only on Earth. You can find this in other planets as well. Yeah, but whether or not they become organism, that's a different story. But if you just talk about building blocks, if you just talk about amino acids, if you just talk about nucleotides, you can find those in other planets. You can. Water, not only on Earth, you can find water in Mars. You can find water in comets. They have ice, you know. But whether or not they support life, that's a different story. Whether or not this amino acid and these nucleotides, they become polymer and they become life, become organism, that's a different story. But you can find building blocks, all these building blocks in other planets as well. You can find. Yeah. But so far, life can only be found on Earth. Yeah. But building blocks everywhere. Organic molecule you can find in other planets. Organic molecule, yeah, small organic molecules you can find in other planets. Yeah. Does it mean that we can find life in other planets? I don't know. Whether or not we can meet aliens one day who come from other planets or other stars, other galaxies, I don't know. Yeah. But for your information, we can find all these building blocks in other planets. All right. So sorry. Yeah. So the difference is between DNA, RNA again is the sugar. Yeah. In the sugar, this one. This is the sugar, right? For RNA, is a ribonucleotide, so you have OH here. For DNA, is deoxyribonucleotide, so you have H here instead of OH. Yeah. All right. So another difference between DNA and RNA is this. Yeah. In DNA, you have T, you have thymine. Yeah. It has methyl group here. But for RNA, you have uracil without methyl group here. All right. The rest of nucleotides are the same. Yeah. A, G, and C. Yeah. Between DNA and RNA, they are the same. Only for T. Yeah. In DNA, it's called T. In RNA, it's called U, uracil. Yeah. So that's the difference. Okay. All right. Okay, so upon hydrolysis, yeah, under different conditions, both nucleic acid yield phosphoric acid, yeah, sugar, and bases. Okay, because as you know, nucleotide has three components. It has a phosphate group, it has sugar group, yeah, and it has a base, which is a nitrogenous base. So this is what happens when you hydrolyze a nucleic acid. Okay. DNA was discovered by these three guys. Yeah. The name is Crick, Watson, and Wilkins. Yeah, Crick, Watson, and Wilkins. Yeah. So they got Nobel Prize in 1962 for their discoveries concerning the molecular structure of nucleic acid and its significance for information transfer in living material. It's huge discovery. Yeah. They discovered the molecular structure. The story is very, very interesting how they discovered this molecular structure, because actually the person who discovered the molecular structure is not them. It's a lady. Yeah. She's a lady. Yeah. But because it's women, so her name is not, the culture is different. During that time, they don't give much opportunity to women. Yeah. So the person who discovered the structure of DNA is not them. Yeah. I forgot her name. Yeah, I forgot her name. Yeah, I forgot her name. I need to find her name. Yeah. So she's the one who discovered the structure. Even she put it in her logbook. Yeah. Even the logbook is, is still being kept in a museum until now. So people can see how she, record everything in her logbook. Yeah. That she discovered the structure of DNA. And one day, she gave her logbook to these three guys. And these three guys used this discovery to come up with the structure of DNA, and they got Nobel Prize. But the lady who initially discovered the structure of DNA did not get Nobel Prize. Yeah, he did not get the recognition that she deserved until she died. Okay, so it's quite sad actually. But now, one university used her name to recognize her discovery of the structure of DNA. Yeah. Finally, okay. So this is the model that they use to show the structure of DNA. They use metal anyway. Yeah. Because during that time there is no plastic 3D model that you use today. At that time they use metal. They join metal, plate metal, metal rod, so it's quite difficult to get the structure. And this metal model still being kept in a British museum in London. Yeah. So this is DNA. Yeah. This is a molecule of life. You have this DNA in your chromosome. Yeah. So we have 23 pair of chromosome, just like this. Yeah. You saw this on my lecture on Wednesday. I show you this. Yeah. Kalau you tarik, if you extend them, you get all this DNA strand. Yeah. Why it has to fold? Because the space in your cells is limited. So that's why this DNA chain, DNA strand, has to be folded into certain structure so it can fit inside your cell. Yeah. So that's how smart nature is. Okay. So DNA is a molecule of life. Yeah. It's a polymer of nucleotides. Yeah. So each nucleotide composed of base, of course, sugar and phosphate. Yeah. And for DNA, it has a double-stranded helix. Okay. Yeah. So for RNA, yeah, it's different. Yeah. RNA was discovered by these three guys. Yeah. Robert Hawley, Gobin Khorana, and Marshall Nirenberg, for their interpretation of the genetic code and its function in protein synthesis. Yeah. So you see the word here, protein synthesis. Yeah. So protein comes from RNA. Yeah. So DNA becomes RNA, RNA becomes protein. This is a ribonucleic acid, which is RNA. It's single strand helix. Yeah, a single strand. It's different from DNA. It has a ribose sugar, not deoxyribose. For DNA, it has deoxy. So they lose one oxygen. Lose one oxygen. Yeah. So instead of thymine, instead of T, yeah, they have a U. Yeah. All right. So it's present mainly in extranuclear. Yeah. So outside the nuclei, because RNA is needed for the synthesis of protein in ribosome. Okay. All right. There are three types of RNA. Yeah. You saw this on Wednesday as well. Yeah. mRNA for messenger RNA, ribosomal RNA, and transfer RNA. All right, so it's 10:56. Can we have a break for 5 minutes, maybe? Yeah. So, right, so I'll see you in 5 minutes. Thank you. Anything in chat? Sorry for late.
Doctor,
Yes,
when is our test one will be held?
week 8.
Oh.
You can refer to, wait, yeah, you can refer to our teaching plan. Let me see my teaching plan. Test 1. Test 1 will be on 25th. 25th of November. Today is 13, right? Yeah, 25th of November, Wednesday, during our
So,
class.
week 6, Doctor.
Itu week berapa? Cek. Week 6, yes, week 6, sorry. Yeah, week 6. Now it's week 4, right? Week 4. Yeah, week 6 on Wednesday, 25th, inshallah.
Okay, Doctor, thank you.
All right, so, okay, so we take a break. I'll see you in 5 minutes. All right, so we continue. Welcome back. Sound check. Suara saya boleh dengar ya?
Boleh.
Okay, all right. So, okay, so we discussed about DNA, about RNA. So basically, they're different, yeah. And you can see the structure of DNA here. Yeah, DNA is double helix, yeah, and RNA is a single strand helix. Okay. And the interaction between strands in DNA happens through hydrogen bond. Okay, so either 2 hydrogen bond or 3 hydrogen bond. Eh? Okay, so that's the force that maintain the integrity of DNA. Okay, so I hope you know the differences between DNA and RNA. In terms of sugar, for DNA, it has deoxyribose, so that's why the name is DNA, deoxyribose nucleic acid. For RNA, it's ribose. And for bases, the difference is only one. Yeah, for DNA, it has T. For RNA, it has U. Yeah. In terms of strand, DNA is double strand, RNA is single strand. DNA, most life has DNA, yeah, but some viruses has RNA. Enzymatic, for RNA, many RNA comes with enzymatic properties, yeah. And then in terms of structure, DNA is double helix and RNA is linear or folded. Yeah, so that's the difference between DNA and RNA. Not only the name is different, but their function is different as well. Okay, now let's talk about the nucleotide, the building blocks. Yeah, so we talk about DNA and RNA. Now let's talk about the building block. Okay, so it's a monomer of nucleic acid. It's a high energy compounds. Yeah, it's a messenger. Sometimes it acts as coenzymes, and it involves in a metabolism as well as metabolic intermediates. Okay, so again, this is a composition of nucleotide. Yeah, so it has 3 components. Yeah, I need to repeat this so that you will not forget. It has phosphate again, yeah, diphosphate or triphosphate, yeah, and then sugar and then base. So nucleotides are the monomeric acid of nucleic acid, yeah, and it has sugar, ribose, and then for deoxyribonucleotide, it has sugar and deoxyribose. Yeah? So you know that. So proteins are polypeptides, yeah. So that's the difference between protein, carbohydrate, and nucleic acid. Protein are polypeptides, so it's a polymer of amino acid. Carbohydrate are polysaccharides, that's a polymer of sugar molecules. And nucleic acids are polynucleotides, so the polymer of nucleotides. Okay, so this is nucleotide, yeah, with T, yeah, nucleotide. So it has 3 components: phosphate, sugar, and base. Yeah. When you remove the phosphate group, what you have is nucleoside. Yeah. So that's the difference between nucleotide. Yeah. In nucleotide, you have everything. You have phosphate, you have sugar, you have base. In nucleoside, you remove the phosphate group. Yeah. Then you have nucleoside. Yeah. It's the difference is T and S. Okay. Yeah. So you don't have phosphate group anymore. Yeah. Okay. So this is the esterification process. Yeah, this is the esterification process. As you can see here, this is an ester basically. Yeah, it's happen at the 5th or 3rd hydroxyl group of the pentose sugar. So either you have diphosphate or triphosphate. Yeah, most of the nucleoside phosphate involved in the biological function are the 5' phosphate. Yeah. So this one, 5' phosphate. Okay. So for nucleotides, little bit about nucleotides. Yeah. Phosphate ester of nucleosides. So when you have nucleosides is without phosphate, right? When you add phosphate, then it becomes nucleotide. Yeah. Base plus pentose sugar plus phosphoric acid is a nucleotide, and nucleotides are polyfunctional acid. Yeah. The pKa is around 1.0 for the phosphoryl group. Yeah. At physiological pH, it has negative charge. Physiologic pH is pH 7.2. Yeah, that's the physiological pH. Yeah. pKa value of a secondary phosphoryl group is minus 6.2. Yeah. So it serves as proton donors or acceptors at pH value approximately 2 or more units above or below the neutrality. Yeah. So the secondary phosphoryl group, as maybe I show you. Yeah. Yeah, this is the first phosphate, and this is the second phosphate. Yeah. So it's a proton donors. So the process of removal or the process of addition phosphate, it requires or it releases energy. Yeah, because it involves proton donors and also it involves accepting the protons as well. So this process is the process that gives you energy. Yeah. So this process of removing one phosphate group, the process of joining one phosphate group, this process will give you energy. Yeah. It's amazing to see that all the energy that we use in our body comes from this very simple process. You remove one phosphate group, you add one phosphate group, it requires some energy exchange and it becomes our energy. Yeah. So it's amazing to know that our energy comes from this phosphate group, whether they join with the whether with nucleosides or with ATP, you know, or when you remove it, it becomes ADP or becomes nucleoside. Then some energy exchange will happen. So when you combine base with pentose sugar without phosphate group, you will get nucleoside. Yeah, it's just to re-emphasize the concept again. Yeah, a nucleoside is esterified to a phosphate group, then it become nucleotide or nucleoside monophosphate. Yeah, they are the same. Yeah, you can call them as nucleotide, or you can call them as nucleoside monophosphate if you have one phosphate group. Yeah, so that's why it's called monophosphate. Yeah. So a second phosphate gets esterified to existing phosphate group, it becomes nucleoside diphosphate. Yeah, and then you add more phosphate group. Yeah, it becomes ATP. We call it as nucleoside triphosphate. Yeah. So either you have nucleoside monophosphate, nucleoside diphosphate, or nucleoside triphosphate. Yeah, but we can call them as nucleotide as long as you have a phosphate group. We're going to call them nucleotide. Okay, so let's dissect one by one. So as you know that nucleotide consists of 3 components. You have base, you have sugar, and you have phosphate group. Now let's talk about the base. Yeah, it's a nitrogenous base. Yeah, it has nitrogen. So the bases can be pyrimidine or purines. Yeah, the difference is in the structure. Yeah. It's a heteroatoms. Yeah, because it has not only carbon but other atoms as well. This is the difference. You need to be familiar with the numbering of both rings. This is pyrimidine, smaller ring. This is purine, yeah, larger ring. Yeah. So this is the numbering. Yeah, you start numbering from N, 1, and then you go to the left. 1, 2, 3, 4, 5, 6. So the same thing with purine. you start numbering from n. Yeah, this is 1, and then you start 2, 3, 4, 5, 6, and then 7, 8, 9. Yeah. So again, pyrimidine is smaller ring, purine is a larger ring. Yeah. Okay, purine base. Yeah. It present in RNA and DNA. Yeah. Adenine is 6-aminopurine. Guanine is 2-amino-6-oxopurine. Yeah. So this is the structure. This is the purine ring. And if you have adenine, you have NH2 here. If you have guanine, you have NH2 in this position and oxygen. Yeah. So that's the difference between adenine and guanine. Okay, right. This is a quite special purine basis. Yeah, it's quite rare to be found. Yeah, a small amount in nucleic acid. Yeah, we call it as minor base. It's hypoxanthine and xanthine. It's quite rare. Yeah, so it's not common to have this minor purine base. Yeah. Uric acid as well. Yeah, this is minor purine base as well. Yeah, uric acid. Yeah. It's an end product of catabolism of other purine bases. Yeah. It can exist in the anol as well as a keto form, so they can form a tautomer. Yeah. So as you can see here, they form tautomer. Yeah. Tautomer means the difference in terms of the hydrogen. So it's a lactam or keto form. So they can become lactim or anol form of uric acid. Yeah, so they can exist in the anol or the keto form. Yeah. So keto form is the predominant type under physiological condition. Yeah, and for some people with uric acid, because uric acid is not soluble in water, they have deposit of uric acid. Actually, it's uric acid is a product of protein metabolism. Yeah. It's a part of a protein metabolism. So actually your body all the time. The issue is in some people, they produce too much uric acid. Yeah. So uric acid is quite difficult to dissolve in water. So it becomes crystal. Yeah. It becomes crystal and then it starts to develop some deposit in your joint. So when you move your joint, it becomes painful because it's crystal. Yeah, it's very sharp. Yes. So yeah, some people they have this uric acid deposition from the overproduction of uric acid. Yeah. You don't have uric acid problem doesn't mean that you don't have uric acid in your body. You do have. It's part of normal metabolism. It's just for some people it's too much. Yeah. So those with uric acid problem, they are advised to reduce the protein intake. They are advised not to eat too much protein, otherwise the uric acid will be produced excessively, yeah? and you got problem with uric acid. Okay, that's purine. Now about pyrimidine. Yeah. So pyrimidine bases are present in nucleic acid. Yeah, they are cytosine in DNA, RNA. Thymine only in DNA. Uracil only in RNA. Yeah, so this is the structure. Uracil and thymine. The difference is this one. It has methyl group. For thymine, for uracil, it doesn't have methyl group. And this is a pyrimidine and cytosine. Yeah. Yeah. So don't get confused with thiamine. Yeah, thiamine is a vitamin B complex. What you have here is this THY. Yeah? So then don't get confused. There are other modified pyrimidine bases like dihydrouracil and 5-methylcytosine. Yeah, but it's quite rare. Yeah, it's quite rare. Okay, this is interesting. Yeah, this is interesting. We call this phenomenon as tautomerism. Yeah. Sometimes, as you can see here, yeah, G, T, and U can partially isomerize to enol. Yeah, G, T, and U. Yeah. Guanine. Yeah, it can isomerize to iminoform. So you see this oxygen, yeah, carbonyl will become OH. All right, it will become OH. And then what about T? Yeah, T as well. From C carbonyl, it becomes OH. Yeah, and then U as well, it will happen the same thing. Yeah, and then A and C can isomerize to iminoform. Where is A? Yeah, this A. Yeah. So instead of NH2, it becomes NH. Yeah. So the same thing here with cytosine. Instead of NH2, it becomes NH. So the question is, what is the implication of this thing? What is the implication of this thing? The implication is huge. Yeah, the implication is huge. All right. Because what? Because the number of hydrogen bond that they can form is different. Yeah. So, for example, for adenine, yeah, this is the predominant form. All right. So this is the predominant form. So they can form the hydrogen bond through this end. Okay, they can form the hydrogen bond through this end. Yeah. So it forms the bonding with H. All right. But the issue now, when this adenine, yeah, becomes their iminoform, this is the iminoform, this nitrogen is blocked. Yeah, this nitrogen now is blocked with hydrogen, so it cannot form a hydrogen bond anymore. So the adenine that normally will pair with T, now they cannot pair with T anymore. Yeah, because A will pair with T, G will pair with C, right? So A that should pair with T, now they cannot pair with T anymore, because this nitrogen that is available to form a hydrogen bond now is not available anymore when the alanine is in iminoform. Okay. So what is the implication? The implication is mutation. Mutation will happen. Mutation in your nucleic acid. Mutation in your DNA and RNA. Okay, because now they cannot form a nice pair. Yeah, A with T, G and with C, they cannot pair. They cannot form a nice pair. Yeah, so mutation will happen. If this mutation happen uncontrollably, yeah, you cannot control it. Your body cannot control it. The implication is you will get cancer. Okay, you will get cancer. Most cancer happens spontaneously. We don't know the reason why. Because what? Because you see this. Yeah, you see this. This process happens spontaneously. It's equilibrium. Yeah, even though on the left side, they are the predominant forms, but there are chances that you will have this tautomer. When you have this tautomer and you are not lucky, all right, this tautomer will cause mutation in your DNA or RNA if you are not lucky, if you are unlucky. Yeah, see all these things. You don't need to smoke. You don't need to smoke. You don't need to eat some carcinogenic. You don't need to you don't need to eat fast food. Some mutation happen naturally in your DNA and RNA because of all this tautomerism. It happened naturally. Yeah. Just by grace of God, you don't get cancer because you have an enzyme called exonuclease that will correct. If mutation happens, they will correct the sequence of DNA and RNA. So, but if your exonuclease is not working properly, there is no correction mechanism. If mutation happen, then mutation will happen uncontrollably, and at the end of the day, suddenly you get cancer. You have healthy life, you don't smoke, you don't drink alcohol, you eat healthy food, you exercise, but still you get cancer. Now you know the reason why. Because of this tautomerism. Yeah. Because of this tautomerism. Yeah. Fortunately, we have some mechanism to avoid this thing from happening. But if that mechanism for some reason stop working and mutation happen, so yeah, so that's the reason why a few years ago, there is a paper published. Yeah, it's about why some people got cancer. The answer is they are not lucky. Yeah, they are not lucky. Yeah, you can avoid cancer by luck. Yeah? So life, sometimes there is a component of luck in life as well. Yeah, so don't forget that. So it's a very interesting mechanism. It's a cancer biology is very interesting, because by looking at this, I have some impression that luck does exist. Yeah, sometimes we underestimate luck, right? Oh, I work very hard. For sure, I will get A. For sure, I pass my exam. But don't forget, even by learning cancer biology, I know that luck plays quite important role to determine whether or not you will get cancer in your life. Just by looking at this, all this process happened spontaneously. You don't need carcinogenic to let this process happen. Okay, so that's a summary. Yeah, major bases in nucleic acid. Yeah, AGCT. Yeah, if you have RNA, it becomes U. Yeah. For AG, the base is purine base. Yeah, consists of two bases, adenine and guanine. And for pyrimidines, which is CTU, so you have cytosine, thymine, and uracil. All right. Okay. Nucleosides. Yeah. So we talk about nucleotide. Yeah. Now what happens when you remove the phosphate group? Then you have nucleoside. Yeah. So you have nucleoside when you have base attached to pentose sugar, yeah, without phosphate group. Yeah, remember that. All right. So you have base, and you have this sugar, and you have this glycosidic bond, yeah, between sugar and base. Yeah. So the way you name it is using a prime number to avoid confusion with the carbon atoms of the purine or pyrimidine ring. Yeah. So I don't know whether you can see it. This is 1 prime. This is 2 prime. This is 3 prime, and then this is 4 prime. When you download the slides later on, you can see this number even more clearly. Okay. That's how we name the atom, because when you name the base atoms, you don't use the prime. Yeah, it's a 1, 2, 3, 4, 5, 6, etc. But for the sugar, you use prime, so you don't get confused between sugar and base. Yeah. So all the bases are attached to corresponding pentose sugar through a beta glycosidic bond. Yeah. It's between oxygen of the first carbon. Yeah. It's a 1 prime here of the pentose sugar and N9 of purine. This is N9 of purine. Sorry, this is N9 yeah, of purine, or N1 of pyrimidine. Yeah. This is number 1. This is number 9. All right. So it's a beta N glycosidic bond. Yeah. All right. So there are two conformers. Yeah, there are two conformers for this glycosidic bond. It's either syn or anti conformers. Yeah. So because this bond can rotate, Yeah, this bond can rotate. This is single bond. It can rotate. All right. So a static hindrance by the base restrict rotation. Yeah. So even though they can rotate, but it's restricted. Yeah. So it's both syn and anticonformers exist as non-interconvertible. Yeah. There is no equilibrium happens here. Yeah. So it's not like tautomers. Tautomerization happens spontaneously, but syn or anticonformers can only be interconverted by cleavage and reformation of the glycosidic bond. Yeah. So it's not, it doesn't happen spontaneously. Yeah. So you have to cleave the bond and then reform the bond. Yeah. Both conformers occur in nature, but the anticonformers predominate. Yeah? This is the anticonformers. They predominate because they have smaller steric hindrance. Yeah? This syn has a lot of steric hindrance. Yeah? And this one is more favorable because this conformer has less steric hindrance. Yeah? All right. Okay, now is 11:34. Yeah, it's slide 35. Yeah, I think I will stop here. Yeah. Now is slide 34 of 63. So we will continue next week. Yeah. Still with nucleotide and nucleosides. Okay. Any question?
Doctor,
Yes.
like tautomerism, it cannot occur because of the factor of parent or keturunan. Always spontaneous,
Always spontaneous. Always. Always
not
spontaneous.
because parent.
No, spontaneous. Yeah. So that's why some people, they got cancer, but their parents are okay. Their grandfather are okay, and suddenly you get cancer. Yeah. So it's not because of inheritance. Yeah. It happens spontaneously, just because you are unlucky. Yeah. Just because of unlucky. The more you learn about cancer, the more you see that a lot of things happen spontaneously. Yeah. Of course, some cancer is based on genetics. Yeah, it's based on genetics. Some people, they have higher risk to get cancer. Yeah, but some cancers, they can happen spontaneously for some reason. Yeah, even right now, mutation is happening. I tell you, mutation is happening. It's happening 24/7. Yeah, but why you don't get cancer? Because as I mentioned, you have this enzyme. It's called exonuclease that will correct that mistake, that will correct that mutation to make sure that the mutation will not stay and affect you. But if that enzyme, for some reason, one day it stops working, then you will get cancer. All right. So the question is how to make sure that this mechanism, this correction mechanism, is in place. Well, a lot of people ask me, doctor, how to make sure that, because now we are relying on that correction mechanism, because tautomerism happens spontaneously. So we rely on exonuclease. We rely on that enzyme to make sure that mutation will not stay. Yeah. A lot of people ask me, doctor, how to make sure that exonuclease, that correction mechanism, is in place? My answer is, do things that make you feel good. You eat well, you sleep well, don't get stressed out. Do everything that makes you good, that makes you feel good, to make sure that all your metabolism process are in place and they don't stop working. Okay, eat well, sleep well, rest well, don't get stressed out. That's it. Easy, right? Okay, any other question? No question, eh? Okay, no question? Yeah? Tak ada? Okay. I just need answer yes or no. All right. So if no question, then we'll continue next week. Yeah. So enjoy your weekend. Have a nice weekend. I'll see you next week. Right. Okay. Thank you. Assalamualaikum. Bye bye.
Thank you, Doctor.